Alright, objective 3 is we're going to start solving polynomial equations, and we're still doing 3.5. So let's go to our note paper. So we can write some notes here about our rational functions. Alright, so the next thing we're going to look at are vertical, well actually, let me just put it like, they're going to be asymptotes. Alright, there's 3 different types of asymptotes. One of them, the first one we're going to talk about is vertical asymptotes. And I guess I really should have called this asymptotes and holes. Okay, so vertical asymptotes. A vertical asymptote, it's a vertical line that the graph will never, ever, 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 ever cross. Okay, so it's going to get super close to it where it almost looks like it's touching it, but it won't. Alright, so to find your vertical asymptotes, they are the uncancelled factors in the denominator set equal to 0. So, because they're uncancelled factors, that means we need to factor the numerator and the denominator first, okay? And cancel out what we can. If we still have a fraction left at the end with x in the bottom, then the uncancelled factors in the denominator, set them equal to 0, solve them, and they'll tell us where our vertical asymptotes are. Alright. Along with vertical asymptotes, I'm going to include holes. This lesson doesn't really talk about it, but you need it in order to graph it, so we're going to go ahead and cover it. Holes are the canceled factors in the denominator set equal to 0. Alright, so when we solve that vertical asymptote, we're going to end up with like x equals a number, okay? And so that is our vertical asymptote. It's a line, it's a vertical line, so it has to have x equals and whatever the number is, okay? When we take that canceled factor in the denominator, we set it equal to 0, we're also going to get an x equals, but a whole is going to be an ordered pair. Alright, so when you solve that, x equals whatever the number is going to be for the whole, you're going to need to take and plug that back into the factored rational function and solve that to find its y value. And we'll do some of them, okay? Alright, then the second type of asymptote we're going to talk about is the horizontal asymptote. Horizontal asymptote is a horizontal line that our graph will never ever cross at the ends of the graph. So on the far left and the far right, it will never cross it. It's going to go towards that horizontal asymptote, but it could sometimes cross in the middle, okay? So to find this, well, there's different ones. You got 3 different things to do. You have to find the highest power of x. Has to do where the highest power of x is at, okay? If your highest power of x is in the numerator, your horizontal asymptote is none. It doesn't exist. If your highest power of x is in the denominator, your horizontal asymptote will be at y equals 0. And so to remember these, what I do is I use no to help me. If it's on top, it's none. If it's on bottom, it's the y equals 0, okay? No. But what if it's in both? Well, if it's in both, we're going to take the ratio. It'll be y equals the ratio of the leading coefficients. So we call that y equals a over b, where a is the coefficient in front of the x to the highest power in the numerator, and b is a coefficient of x to the highest power in the denominator. And then the third type of asymptote we talk about is a slant asymptote. All right, a slant asymptote, it's a slanted line. It's a linear line. So when we graph it, it'll be linear. Okay. It only exists if the degree of the the degree of the numerator is greater than the degree of the denominator by 1. So at the top is x cubed and the bottom is x squared. At the top is x to the 10th and the bottom is x to the 9th, okay? Has to be by 1. The nice thing about this is if you have a slant asymptote, you will not have a horizontal asymptote, because that means the numerator would be greater, which means the horizontal asymptote would be none. So you'll never have a slant and a horizontal. You'll either have one or the other, or neither, but never ever both, okay? And so we're going to find this using division. So depending on what we're dividing by, what the denominator is, you could use long or synthetic, okay? Remember, we can only use synthetic division when it's x and then plus or minus a number, okay, an integer. Otherwise, we have to use long division. All right, so let's try some of this. So let's go back to our notes here. All right, and so objective 3 talks about vertical asymptotes. And so we're also going to find the holes with it, okay? So it says find the vertical asymptotes and holes if any of the graph of the rational function given here. All right, so first thing we need to do to find the vertical asymptote is we are going to have to factor this out. And so my denominator does factor here, so I'm going to do that. So we get x minus 1 over, that's a difference of squares, so x plus 1, x minus 1. Simplified if possible, so my x minus 1's cancel. So I don't have anything left on top, so I put 1 over, and then I have an x plus 1 in the denominator. Remember, your vertical asymptotes are your uncancelled factors of the denominator equal to 0. Well, we have that x plus 1 still in the denominator, so it was uncancelled. Set it equal to 0 and solve. And so we have a vertical asymptote at x equals negative 1. Then, do we have any holes? Remember, holes are the cancelled factors of the denominator. Did anything cancel? Yes, the x minus 1 canceled. So we're going to set that equal to 0 and solve. So that means we have a hole when x is 1. But a hole is going to be an ordered pair. So if we know that x is 1, we found over here that our y is equal to 1 over x plus 1. So we're going to take that 1 and plug it in. So 1 over 1 plus 1, which is 1 over 2. So we know our x is 1, our y we said is 1/2, and so our hole is going to be at 1 comma 1/2. All right, let's try pencil problem number 3. So again, we're looking for the vertical asymptote and holes. So we need to see, we need to simplify our fraction if possible. So our x is a cancel, nothing left on top, so 1 over x plus 4. So do we have a vertical asymptote? Well, do we have any uncancelled factors in the denominator? We do. We had x plus 4. So we're going to set that equal to 0 and solve. And so we have a vertical asymptote at x equals negative 4. Do we have any holes? Did we have anything cancel? We did. So we're going to set that canceled factor equal to 0 and solve. Well, it's already solved for x. Once you find x, remember, plug it into your simplified rational function up here to solve for the y value. And so we got 1/4. And so our whole is it when x is 0 and y is 1/4. All right. Moving on along here then. So solved problem 3b. We're going to find the vertical asymptote there. So factor again if possible. Oops. Can't factor the numerator, but I can't factor the denominator either. Okay, because it's a +1. This is not a difference of squares. So when I go to do my vertical asymptotes, uncancelled factors of the denominator, does anything cancel? It does not. So the uncancelled factors, x squared plus 1, set that equal to 0 and solve. So x equals plus or minus I. Now, a vertical asymptote is that line that's dealing on our x-axis. We don't have any i's on our x-axis, which means because our vertical asymptote, we said it was imaginary, there are really not any, so there's no vertical asymptotes. What about wholes? Wholes are the canceled factors of the denominator equal to 0. Did anything cancel? It did not cancel, so there are no wholes either. All right, so pencil problem 3b here. We're looking for vertical asymptote and wholes. So we need to factor this as possible, and we can't factor it. That's not a difference of squares in the denominator. Nothing cancels, so our vertical asymptote, remember our uncancelled factors of the denominator equal to 0, so that x squared plus 4 equals 0. Some of you may notice, oh, this is a sum of squares. We automatically know it's going to involve an I, but if not, that's okay. You can solve it out. When you take the square root of that -4, you get plus or minus 2i. And so because it has an I, it means there's no vertical asymptotes. Okay, for wholes, remember wholes are those canceled factors of the denominator. Did anything cancel? It did not, so that means there's no wholes. All right, moving on along, we talked about in our notes about the horizontal asymptotes. And so, remember, this is where I use no to help me, or it's y equals a over b. So, it says find the horizontal asymptotes of any of the graph of this rational function. So, horizontal asymptotes is where we look for that highest power of x. So, notice, the highest power in the numerator is x squared. The highest power in the denominator is also x squared. So this one is on both. Well, we said both was that y equals a over b, where a is the coefficient in the numerator. So let me erase my circles here for a minute. So the coefficient in the numerator is a 9 over b is the coefficient of that term in the denominator, so a 3. And 9 over 3 reduces to 3. Now, because it is a line, we need to take the work out of the middle there, so our horizontal asymptote is at y equals 3. All right, pencil problem number 4. We're still looking for that horizontal asymptote. So look for that highest power of x. And notice in the numerator, it's x to the first, and the denominator, it's also x to the first, so it's both again. It exists in the top and the bottom, the numerator and the denominator. All right, so we know it's going to be, for the horizontal asymptote, it's going to be y equals, you have to put y equals, and it's going to be the coefficient of the numerator and the denominator there. So it's going to be the -2 for the numerator, over 3 for the denominator, so y equals -2/3. All right, then solved problem 4b. We're still looking for the horizontal asymptote. So find that highest power of x. Notice in the numerator the highest power is x cubed, but in the denominator it's only x squared. So the highest power here is in the numerator. So if it's in the numerator, or the denominator, remember I use no to help me. And so the N is for the top, which stands for none. So your horizontal asymptote, there isn't one. It doesn't exist for this problem. Pencil problem 4B. Still after that horizontal asymptote, find your highest power of x. Notice this time it's in the denominator. Okay, if it's in the denominator, again, I use no to help me. And it's that O, which is the y equals 0. So therefore our horizontal asymptote is at y equals 0. Alright, so I'm going to stop this video and I'll start up again in just a second.